We have natural instincts about the space in which we live. We can describe the locations of objects in this space. There are many things in nature which are similar to our instincts about the space in which we live. The space in which we live, I will call it real space. So, real space refers to the physical, tangible expanse of the universe where all material objects exist and natural phenomena occur. Real space is the space we observe in our daily life, which is three-dimensional. Objects in real space have specific locations. Examples of objects in real space include Sun, Moon, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, you, me, they, everyone. There are many things in our daily life which are similar to the real space, and we can gain new insights about them by representing them like real spaces. And using our instincts about real spaces, we can gain similar insights about those similar things. I will call those representations abstract space. Abstract spaces lack physical existence but has mathematical properties like physical spaces.
Analytical geometry was given by French mathematician and philosopher René Descartes. Analytical geometry is an extension of the number line on which we start with an origin with coordinate 0 and we take an unit length which is equal to 1. And the value gets increasing if you go this side, and the value decreases if you go this side, like -1, -2, -3, -4, and it keeps decreasing. We know that if 3 units of length is added to 3, if 3 units of length is added to 2 units of length, we will get 5 units of length, right? And if we subtracted 3 units of length from 2 units of length, we will get -1. The same thing is true for. So it's a good idea to represent these quantities as length. Similarly, in 2 dimensions, we have the x-axis and the y-axis. We choose 1 unit on both sides, on both axes, and make grid lines at equal intervals equal to the unit and mark them as shown. We can locate a point using just 2 numbers, the value on the x-axis and the value on the y-axis, like this. The value on x-axis is written first and then the value on y. On the number line, we only had one axis, so we were limited to represent only one physical quantity. But in 2D Cartesian coordinate geometry, we have 2 axes. So we are free to represent 2 physical quantities on each axis. We can represent 2 physical quantities simultaneously. This way we can gain geometrical insights about their relations, like how one physical quantity relates to other physical quantity. Coordinate geometry helps us bridge the gap between algebra and geometry.